All right, let's get right into it. We're going to break down one of the most important papers in modern AI history. This is the one that really introduced the world to GPT-3, and with it, a totally new way for machines to learn.
So let's start with a really fundamental question, right? How do you actually teach an AI a new skill? Let's say you wanted to translate French to English, or maybe answer some trivia questions. Where do you even begin?
Well, for the longest time, the answer was basically just brute force. You had to feed it a mountain of data. We're talking about a massive, custom-built data set for every single task, often with millions and millions of labeled examples.
Yeah, this was the standard way of doing things for years. It worked, for sure, but man, it had a major bottleneck.
This old method is called fine-tuning, and it meant that for every single new task you wanted the AI to learn, you had to go back and retrain a huge model with thousands of fresh examples. It was incredibly slow, super expensive, and just a massive pain. The new idea, though, few-shot learning, is a whole different ballgame. It guides the model with just a couple of examples on the fly.
But the researchers behind GPT-3, they had a really radical idea, something that felt, well, a lot more human.
And this new method is called in-context learning. Now, instead of completely retraining the model, you just give it instructions and a few examples, a few shots, right there in the prompt. You just show it, say, sea otter, arrow, loutre de mer, and boom, it gets the pattern. It learns what you want it to do from that context alone. No new training, no complicated updates. It's kind of like showing a person a new type of puzzle. You don't have to re-engineer their brain, you just show them a couple of examples and they figure it out.
So the huge question was, could this in-context learning thing actually work for really complex tasks? I mean, it's a great theory, but does it hold up? To find out, the researchers at OpenAI set up an experiment on a scale nobody had ever seen before.
They basically made a huge bet on one simple but incredibly powerful idea: scale. Their hypothesis was that if they could just make a language model big enough, like ridiculously big, these amazing learning abilities would just emerge on their own. And this graph here, this was their guiding star. It showed that as they threw more computing power at the problem, the model's error rate just went down and down and down in this really smooth, predictable curve. It was a power law, which basically meant more scale equals a better model. Simple as that.
And when I say scale, I really mean scale. They didn't just build one model. Oh no, they built a whole family of them, starting with one that had 125 million parameters, which was already considered pretty big back then, and then just kept climbing the ladder, step by step.
All the way up to the final boss, a model with 175 billion parameters. Just to put that into perspective for you, that is over 100 times bigger than its predecessor, GPT-2. And it was trained on a mind-boggling 45 terabytes of text from all over the internet.
So, they ran the experiment. They built this absolute giant of a model. And what happened? Well, the results were just stunning. The model didn't just get a little better at predicting the next word, it started developing entirely new skills, surprising skills that nobody expected.
First up, translation. Look at this. With just a few examples tossed its way, GPT-3's French to English translation quality, that top line there, actually shot past the best systems available at the time. Now think about that for a second. It beat models that were painstakingly fine-tuned only for translation. GPT-3 just picked it up on the fly.
Then you have general knowledge. On this Trivia QA test, the biggest GPT-3 model, that's the orange line here, once again, it blew past the state-of-the-art models that have been fine-tuned for this exact task. The implication is just amazing. It could answer trivia questions better than a specialized model, just by seeing a few examples.
But this is the result that really made everyone's jaws drop. Arithmetic. Just look at this graph. The smaller models, they're basically just guessing, right? They're all over the place. Then, out of absolutely nowhere, the biggest model suddenly jumps to nearly 100% accuracy on two-digit math. This wasn't a gradual improvement. This was what we call an emergent capability, a skill that just popped into existence once the model got big enough.
So what's the real-world result of all these new skills? The model became an incredibly fluent, incredibly convincing writer. So much so that when researchers asked regular people to tell the difference between news articles written by a human and articles written by GPT-3, well, their accuracy tanked. For the full 175 billion parameter model, people were only right about 52% of the time. That's basically a coin flip. They were just guessing. Now, this kind of power is revolutionary, no question about it. But with that power comes a whole lot of responsibility and risk, and that's something the original paper actually spends a lot of time digging into.
The authors themselves really hit the nail on the head. They summed up the core problem perfectly. When you train a model on a giant chunk of the internet, it doesn't just learn the good parts.
It also learns our biases. This analysis from the paper, for example, shows how the model started to connect different feelings or sentiments with terms for different races. It learned to associate certain jobs with certain genders and to describe women using words about their appearance way more often than it did for men. These aren't glitches. They are a direct reflection of the stereotypes floating around in its training data.
And beyond these ingrained biases, this is the very real potential for people to use this tech for malicious stuff. The exact same power that makes the model so helpful can be flipped around to generate high-quality misinformation at an incredible scale, create super believable phishing emails, automate online harassment, or even just turn out fraudulent school essays.
The GPT-3 paper proved that scale isn't just about making models a little bit better, it's about making them fundamentally different. It unlocks abilities we never explicitly programmed and honestly couldn't even predict. Now, that was the power of scale back in 2020, which leaves all of us with a really crucial question. What new, completely unexpected abilities will the next great leap in scale unlock?